Let's talk about the bypass UAC attack. This is a pretty cool attack, and it's really worth your time to understand how it works. It's a pretty funny story too. The story begins with Windows Vista. Windows Vista was the first version of Windows to introduce the collection of user account control technologies. Okay? And user account control in Windows Vista was also the source of a lot of negative feedback on Microsoft's new operating system. The reason being, users got really tired of being prompted for every privileged thing they tried to do. They got tired of being prompted for file copies. They got tired of being prompted for very routine system use activities. Okay? Microsoft listened to this feedback, and their solution to deal with it was to introduce a mechanism that allows Microsoft programs that are signed with a Microsoft code signing cert and running from a safe folder, like C Windows, to opt out of the UAC prompting. That was the mechanism Microsoft introduced. Now, a gentleman named Leo Davidson didn't like this mechanism. He saw it as pretty anti-competitive. What gives Microsoft the right to make it so that their programs get favorable treatment in terms of ease of use and convenience that other programs are not allowed to have? Okay? So he took great joy in introducing the world to Microsoft's anti-competitive mechanism and the security loophole that came with it. And that's what we're going to go through here. What's funny is this attack really requires two steps, and both steps are made possible by Microsoft's special treatment for itself, okay, but in completely different ways. So let's start the discussion with this. Bypass UAC is a two-step process. First, it takes advantage of a UAC loophole to gain a privileged file copy. The bypass UAC attack uses this privileged file copy to copy an attacker-controlled DLL into a location where it may get loaded into a program that is going to run in a high-integrity context without prompting the user. That's the two steps of this attack. Let's go through them. Here's how the privileged file copy piece works, okay? First, we kick off a program that is running from a safe directory signed with a Microsoft code signing certificate, okay? Notepad.exe is as good of a candidate as any. We then inject our bypass UAC logic into that program. We can do that because both programs are running in a medium integrity context by the same user. So I can inject code into that program. Now that I've got my malicious code running in the process space of this safe, specially treated Microsoft program, I can do some special things. For example, I can load COM objects that receive special treatment when they run from a Microsoft program. So this attack loads the iFile operation COM object. And this iFile operation COM object allows its actions to happen from a high integrity context within a Microsoft signed program running in a medium integrity context, okay? And this COM object gives me the ability to do a privileged file copy. Pretty cool, pretty funny, pretty unexpected. Cool. So I've got the ability to copy my file somewhere. Great. Now, let's talk about the DLL hijacking piece. I use that privileged file copy and copy a malicious DLL to a folder with a vulnerable app. I run the vulnerable app so that it loads my DLL and my malware is executed. Now you may be asking, how does running a program that loads my DLL put me in a high integrity context? Well, again, some Microsoft programs running from a safe folder can choose to opt out of the UAC prompting. So by hijacking one of those programs, I'm basically getting a Microsoft program that will automatically raise itself to a high integrity context to load my DLL. And from there, my code is running in a high integrity context. That is the bypass UAC attack. Okay, we're back where we left off just a demo ago. We have two beacons running in medium integrity context, the BDAID beacon and the lab beacon, okay? Let's go over to the pivot graph so we can see our cool chaining that we're doing. So from the BDAID beacon, let's do whoami/groups. And as soon as this beacon checks in, you will see that BDAID is a local administrator, but we are in a medium integrity context. The command to break out of that is bypass UAC. So let's just go do bypass UAC, local beacon SMB. And there we go. We now have a new beacon running as the user BDAID in a high integrity context. Now in the previous demo, we spawned a beacon as the user lab. Let's do a whoami/groups for this user as well. And you can see that this user is also a local administrator, but of course stuck in a medium integrity context. Same type of thing, we can just do access, bypass UAC, choose our SMB beacon listener, hit launch, and this payload will give us a new session with the lab user running in a high integrity context. So that is the bypass UAC attack. With privilege escalation, one of my favorite tools is PowerUp. PowerUp is a privilege escalation vulnerability scanner written in PowerShell by Will Schrader, okay? And what PowerUp does is it looks for different misconfigurations that can help you elevate. To use PowerUp from Beacon, you just do PowerShell import, the local path to powerup.ps1, and then you do PowerShell invoke all checks to run the PowerUp vulnerability scanner, if you will.